Good evening, everybody. Greetings from Singapore. I'm Kelvin Ang, a member of the Board of Trustees of the Commonwealth Heritage Forum. It's my pleasure to invite all of you this evening or this afternoon to learn a bit more about railway heritage in Singapore. For those who are new to the CHF, we are an innovative membership organization open to all who are interested in sharing in the conservation of built heritage across the Commonwealth. We welcome membership from individuals, heritage bodies and trusts, professionals, as well as academic institutions. My day job is Director of Conservation Management at the Urban Redevelopment Authority, the authority in Singapore that's in charge of land use planning, development, as well as building conservation. And that is why I've had the pleasure of inviting my colleague, Mr. Wong Kia Fu, here to share a bit more about the railway bridges of the Singapore Railway that was handed back to Singapore about 10 years ago, and more recently restored and opened to the public. Mr. Wong is a civil engineer at the URA and has been involved in the structural investigations of heritage structures and bridges along the rail corridor, as well as their refurbishment and subsequent adaptation to new users. He has been overseeing the improvement works to the trail along the old railway and the new pedestrian interventions such as underpasses across the railway corridor. Wong has a keen interest in the adaptation of digital tools to improve construction productivity and safety. He has also implemented digital solutions such as 3D laser scanning and photogrammetry to improve project outcomes, especially for projects with rich heritage. This for us in Singapore is a relatively new development, and I hope what we have done in Singapore can be of help to the rest of the Commonwealth. So over to you, Kia Fu. And for the audience here, if you have questions, please save them for the end of the session. You may also type them on the side of the chat, and we'll go through it in about 45 minutes' time. Thank you, everybody, and over to you, Kia Fu.
Hi, good afternoon, everyone. Staying in the Europe, and good evening to those joining me from the Southeast Asia. It's 9 o'clock in Singapore time now. And thank you for inviting me this evening to share our journey in the design and development of the construction process for the rail corridor. Today, I hope to share with you some of the engagement process, thinking, design consideration, and challenges that we have gone through in working on the refurbishment of the rail corridor. I'm from the Urban Redevelopment Authority. We are, as introduced by Kelvin earlier, we are the Singapore's Land Use Planning and Conservation Authority. Our mission is to make Singapore a great city to live, work, and play. The picture that you see here is our Marina Bay, and I am sure those of you who have visited Singapore, you have likely come to this place. Singapore is an island city-state with limited land for many needs. So we have a population of about 5.9 million this year, of within land area of 733 kilometers square. We are half of London, and Hong Kong is about 1.5 times of Singapore's land area. Within this very confined land area, we have to meet various needs as a city and as a country. Therefore, places like ports, defense, water catchment, greeneries, and so on, all these have to be considered in the limited land. And therefore, we have to plan carefully and reuse and adapt different places to meet our needs as a country and as a city. And from the Development Services Group within URA, we are the engineering arm of the URA, where we plan, facilitate, and implement infrastructure, environmental improvement, and building projects for selected area to facilitate the URA's plans and vision for the city and the area. Some of the more recent and well-known projects that our team has completed are the district cooling system in Marina Bay, which have the world's largest underground district cooling network at the moment, Helix Bridge and Marina Promenade, Kranji Marshes, and the Marina South, where this is just beside Gardens by the Bay, where we are starting to come in to develop this place to serve our future needs. We also do projects, environmental improvement projects. For example, the one over here. Hey, sorry, let me point this, where we upgrade existing underpass to make it more friendly to people of different ages to use and to avoid crossing a pedestrian overhead bridge, so that it's more convenient, especially to people who are on wheelchairs and those who wish to cycle with undisrupted flow from different parks into the city area. And last but not least, as we develop new area, we also work on preparing the infrastructure, for example, sewers, drainage, roads, as well as substation to serve the area. So allow me to do a very brief introduction of the rail corridor and the railway history of Singapore. The alignment that you see here joins from Woodlands all the way to the Tanjong Pagar and Pasir Panjang area. This old alignment was the first Singapore Kranji railway line. This alignment, especially those from Bukit Timah to Tanjong Pagar, this area was prone to flooding back then, and it was subsequently realigned in the 1932. And at the same period, due to the need to expand the main terminal in Singapore to cope with influx of passenger and goods, where this is where our ports are, the Tang Road station, which was the previous station, could not cope and cannot be expanded due to space constraint. Therefore, we built a new Tanjong Pagar train station at this area. And this new alignment in green here is the new alignment that has been in place since 1932. In this new alignment, we have a new Bukit Timah railway station, Alexandra Hall, Tanglin Hall, and as well as the last terminal station at Tanjong Pagar. So this stretch of rail corridor, again, this is Singapore map. We are cutting across the exact center of Singapore. And the north here joins to Malaysia. We have the Kranji area here, and along this rail corridor is about 22 kilometers that goes all the way into the south, Tanjong Pagar. We have about 1 million people living within 1 kilometer radius of this rail corridor. The corridor threads through various industrial estate and business park, and there are also parks and open spaces around it. Within this 1 kilometer catchment, there are also 58 schools and various historical places or point of interest like the War Memorial, Old Ford Factory, the old fire station, and newer commercial area like the Rail Mall, Bukit Timah, and so on. So as we design and try to plan what to do with this rail corridor, we have a lot of stakeholders and communities that we have to engage and reach out to, and each of them actually have their own interests and aspiration. So as a developer, to look after this project, we have to manage their expectation and their aspirations. When it was announced in the 2010, that was 13 years ago, right? The railway operation from Singapore that connects to Malaysia will cease operation because we are shifting the railway out, and those areas from the Woodlands all the way to Tanjong Pagar will stop operation. So the Malaysia will return the land and the railway back to Singapore in exchange for some other items. So when this land is free up, it actually picks a significant public interest on what do we do with this railway land or railway track that is returned to Singapore. The public response opened up an unprecedented opportunity for us to look at the future, how this place can be an enduring and a special place for people to enjoy in different ways. URA, as the planning authority, realized this is we need a public engagement, a proper public engagement strategy to put in place to respond to the residents' concern that the rail corridor has previously being across the middle of Singapore is chance to join the community again. And over the last 10 years, since 2010 until now, about 13 years, we have actually gone through 3 significant phases of the project. In the early 2010, after the land has been returned to Singapore, and we launched a website about the project, and we opened this once the railway authority has salvaged and we remove all the railway track, we actually open the corridor to public for them to just use it as it is condition. We spent about 4 or 5 years on public engagement and various exhibitions. And then in about 2017, we then start to identify this middle track of the rail corridor as a signature stretch. And then we actually did some experiment on different track material to use and what to and how to refurbish the place. In the same year, we formed this group called Friends of Rail Corridor, where residents and interested parties of the rail corridor actually come together and share their views and visions in a more focused group concept, and we work together to identify what can we do for the rail corridor, and then that was the middle part towards implementation. And then from 2018 onwards, we actually started the structural investigation, the construction and design, and construction of the refurbishment work. So we coincide, we started in January 2020, and actually it coincide with COVID, where actually our works are affected in some way. We managed to open the project, reopen the bridges and the trail in 2021. And then in 2022, we opened the Bukit Timah railway station at the 9 Mile platform, which is along the same rail corridor central area, but is developed as a separate project so that we can open up the remaining of the trail earlier, and then we continue the construction of the railway station separately, as it will take a longer time, and we do not want to hold back public from using the space. As we engage the stakeholders, we actually received many ideas, and we distill them into actually 3 key ideas. The people, the stakeholders, they wanted to retain and increase the biodiversity around the area. They wanted the place to be more accessible and inclusive, and we wanted to celebrate our railway heritage. So most importantly, I think within these 3 bubbles here, we wanted to keep this space large, and we don't want to convert it into a modern area. We want to keep it as is today's condition. So we wanted to maintain the look and feel of the project. It's also important as we engage various stakeholders, we have to know that they are not independent. They are always trade-off as we seek to strike a good balance between the different demand and requirements from the different stakeholders. So allow me to zoom into today's topic on the 2 bridges. We have 2 truss bridges along this rail corridor central. This is what we call Upper Bukit Timah Bridge. It is located above Upper Bukit Timah Road, and the other bridge is called Bukit Timah Bridge. Is located above the Bukit Timah Road. The railway station that I mentioned is over here, just next to the Bukit Timah Bridge. So the presentation today, I will be focusing on the refurbishment of the bridges and the journey that we have gone through. To repair the bridge, there are 3 distinct steps that we have gone through. Firstly, we had carried out a structural investigation. These bridges was built in the 1930s. Therefore, there are limited information and records of the materials and the geometries and the design of the bridge. So we have to redo the structural investigation to establish all these parameters, and then carry out design and analysis to make sure that they are still safe to use in the future. And then lastly, we carry out the actual refurbishment and enhancement work to the bridges. As much as I try to explain and go through the steps here in the chronological sequence, some of the activities that I will show later, they actually happen concurrently. So so there may be pictures that you see they come and go because I reuse them at the different slides to show the intent. So some key facts of the 2 bridges. The left is the Upper Bukit Timah Bridge is 43.8 meter long and 6.2 meter high. The other one at Bukit Timah is a Baltimore Truss, which is 48, slightly longer, about 5 meter longer, and is also slightly taller at 6.65 meter high. They were designed by United Engineers Limited in Singapore in the 1930s and built by Dorman Long Co. in the same period. So allow me to zoom into the first part of the process, which is to carry out the structural investigation. The consultant involved is CKMPT International Private Limited. Is a local Singapore firm. Engineer in charge is Engineer Abhishek Modi. So the key things that we have done was to establish the material sizes and geometry. Due to lack of a record, there were no as-built drawing and all this. We carry out ultrasonic thickness measurement to establish some of the key member sizes and their thickness. And then we actually also use laser scanning to scan the whole bridge and reproduce the geometry drawing for the bridge. Then these are all steel bridges, but we need to know their chemical composition so that we can identify the correct repair methods and that is compatible to the steel. The bridges were actually mild steel. It was built in 1930s. We thought they were cast iron material, but actually after doing the test, they are mild steel. And if they are mild steel, actually we can use welding to do repair work instead of cast iron, where actually they are brittle and we cannot use welding. So all these influence how we repair and refurbish the bridge later. Then we also retrieve some pieces. We use destructive tests and non-destructive tests to identify the material strength, and this will help to establish the design the capacity of the bridge. So we have considered the various loading in respect to the Singapore Singapore National Annex requirements. So there will be dead load, superimposed dead load, which are the ballast, sleepers, and rail. They are quite thick, about 400 mm thick of ballast on the bridge. Live loading, wind load, collision load, which we have to consider based on our local transport authority requirement. Because this bridge is just about 4 meters above the road level, we do have to consider like double-decker buses or other vehicles, especially trucks, in case they exceed the allowable size and they hit onto the bridge. The bridge needs to remain stable and safe. And we also consider for corrosion allowance of 1 mm. As much as possible, we have carried out the ultrasonic test to check the thickness, but it's not possible to check the entire bridge. So we checked a few key areas and allow 1 mm reduction when we do for the design check. And based on the different tests that we have carried out, we established that the yield stress actually is 235 Newton per mm square. Then, with the help of the 3D laser scanning, we managed to rebuild the bridge geometry. And then with the geometries, the engineers and then model it in software to carry out structural analysis. Using the load cases that I explained earlier, we have then established that this bridge actually is safe to use by the public in the future. We are currently allowing people to walk and cycle on it. We are not allowing vehicles on it, and the analysis has shown that this is sufficient for this use. We also, I think importantly, we also look at vibration analysis, but this bridge being very stiff and is quite heavy because of the ballast weight, we have no concern on the vibration and the frequency of the bridge. I think one concern that we had earlier was also on the fatigue, because it has been used by the trains over a long time, since 1930s. But we managed to go through we track back the timetable and the schedule of the train back then. So we established that the bridge actually were designed for 200 millions of train loading cycle, but calculating backwards from 1930s until 2010, there were likely only about 500,000 cycles of loading. So we still far away from the design life of 2 million cycles. So in terms of fatigue, the bridge are also in good condition, and we do not have to be worried about that. On visual inspection, we established that there were no fatigue and everything are in good condition. So what we need to do is to carry out local repairs for those members who have rusted or has broken over time. So with the investigation completed and we have established various key engineering parameters for that, we then move on to do a more detailed documentation. The contractor was Tanks Engineering Private Limited, and the survey was done by Jimmy Tan, registered surveyor. So we make use of laser scanning solutions. We just spent 1 day on site, and we have completed 51 scan stations, some below the bridge, some on top of it, and some at the site. And of about 2 weeks of office processing, we can then reproduce the drawings and the structural details, including the details of the numbers of rivets and at each locations with very good accuracy. And we also noted at places like the lacing at the bottom cord, some has been corroded, and all this, but we are able to track and capture all this in the drawing. This will facilitate the engineers further proposal on the design and refurbishment. Then with the help of laser scanning, actually one key advantage that we can obtain is to produce this reflected ceiling plan. As these bridges are above live and busy traffic, busy road. Bukit Timah Road and Upper Bukit Timah Road are both very busy roads in Singapore. It's very busy from all the way from the morning till the evening. So when we carry out repair works at the bottom, including repair and painting, we have to close the lane, and we can only close it at night. Therefore, having a good and accurate plan of the reflected ceiling allow us to plan the lane closure and traffic arrangement very safely and carefully. So we can then overlay both and then At the same time, actually, if you can see, there are also other contractors doing other works nearby, and this allows us to interface and make sure that we don't overlap with one another, and we can repair the bridge in with a minimal disruption to the motorists that have to use the road below. One key things that we wanted to do and we managed to do is we wanted to put all these accessories or track elements back to their original location one by one, so there's no replacement. We remove them, we label and tag them, and we remove it so that we can repair the bridge structural steel plate below the ballast and track. And at the end of the construction, we actually bring them back to their exact location using the exact pieces that were there before we do any work. So all these are labeled carefully on site and digitally, and then we then reinstate them one by one at the end of the project. We managed to also reproduce the track element in CAD, and you can see we can detect very small curvature and bends, which is hard to do if you were just using a conventional total station surveying. We can track the elevations of 3D and XYZ elevations of all the end members of the railway track. If I can zoom in, say you can see the track elements, some of the sleepers have been rotten. We are also able to pick it up from the survey, and we know exactly which member T20, T21 has problem with the sleeper. So after this documentation, we then move on to do the actual refurbishment work. The contractor is Tanks Engineering, and the qualified person, the engineer work on it. The design scheme is engineer Tong Wei Bin. Before we can do anything, we then have to start to think about how do we allow the workers to go up and to repair the different levels of this truss bridge. This truss bridge is about 6 meter plus, as I shared earlier, 6 meter high. So we have then make it into 3 levels so that we can work on the different levels at any one time. With the standard size of this scaffolding pipe in Singapore is 6 meter long, and although the truss bridge is 6 meter high, actually they have diagonal members. So, and having to deal with a 6 meter long pipe, steel pipe, above live traffic is something that is we want to make sure that it is safe. We don't drop any items, and the workers can handle the pipes safely. So we use the 3D model based on the based on the data that we have collected. We then review this model, and then simulated how will the erection sequence of the scaffolding pipe be, and then and some locations we identified that a 6 meter pipe is too long. We have to cut it in 2 pieces of 3 meters, and then erect them accordingly. With this, we then work up a sequence of about 44 steps on step by step which pipe to erect first, and then until the very last step where we have to put a wrap across it so that we can work within the bridge and not disturb the traffic below. So all these are carried out with live traffic below. We make sure that safety is a critical concern here, and we we managed to do it without any disruption to the traffic below and without any incident. So this is how it looks like at the bridge level, where the pipes are done, and this is 2 level long, and at the end the whole bridge is wrapped up and people work on it, and cars remain the road remain open underneath the bridge. So when the scaffolding pipe is up, we have working platform on top of it. We can then start doing the repair work. So one of the things that we have to do is to apply protective paint onto the structure. So we first have to grind off the existing rust on the bridge, and then apply 4 coats of paint. So first 1 primer, and then 4 coats of painting. All these are corrosion and weather resistant paint, and in the end it looks like this in the photo over here. This is what happened on top of the bridge, and at the bottom of the bridge we do the same thing. We have to close the road. You can see we put safety cones, and we have the scissors lift to bring the people up to repair the bottom. So because of these four stages of coating, including if we have to do repair work, each lane takes about one week to do. So grind and then paint them lane by lane, and then we move on to the next lane. So this is at locations where there is indeed damage at the bottom steel member. They are likely damaged by oversized vehicle that has hit the structure previously. So you can see the members are bent. So we carry out one-to-one replacement to this steel member because we cannot fix it on the spot. We have to cut it and then weld a new member back so that it can still carry the weight of the bridge. So this is also done concurrently as we do the painting work underneath the bridge. On top of the bridge, we have to also check the steel decking. And once we open up, actually we saw that there are actually gaps that have been cut for various reasons, and there are holes that previously probably is used for drainage purposes, but we do not need it anymore. So we have welded some plates to cover them and to put enough protection over these damaged plates so that the load transfer is sufficient to pass it to the bigger plate member. So the structure aside, we have to also make this place, and it is also our objective to make this place suitable for people of different ages and ability. This is how the bridge looked like before we do anything. There were only two metal chain link, metal link fence so railing over here. Actually, it's quite exposed. So if you are walking on it and you're playing with your phone, then you may drop your phone and then it will just drop to the road below it. So it's dangerous, and the height is only 1.05. So as we do the refurbishment, we wanted to address this safety concern. It's also public has been reminding and highlighting this concern. So we make sure we solve this problem as we refurbish the bridge. But we do not want to do too much, and we do not want to introduce railing that are too fancy or too modern. We wanted to keep the railing to follow the existing language and the style of the character of the bridge. Of course, we have to comply to our local railing and pedestrian restraint system code. So these are our structural members, and therefore we review and base our design based on the few design codes over here. So because we do allow people to use their bicycle on the cycling bridge, we have to make sure that the railing is high enough to make sure people, when they cycle or when they're standing on the bicycle, they still will not topple and fall out from the bridge. So the railing that is used in the bridge eventually is 1.4 meter high, and this is acceptable standard for bridges that allows people to cycle on it. So we need railing. What is the most appropriate design? So we simulated several options and also consulted the stakeholders. So there are BRC mesh railing with a top bar and without a top bar, some frame and mesh, thin bars, rods, steel plate, and so on. So we created different perspective, and then to allow us to visualize how will this introduction of this new railing member affect the look and feel of the character of the bridge. After that, we then fabricated some mock-up, and then we bring it to site, and we bring the stakeholders to the bridge again to have a look and get them to comment and feedback whether they like the design, whether there's any further improvement that can be done on this. We also push the boundary of the design code and make sure our steel railing are indeed structurally adequate, but is slim enough such that it does not affect the look of the bridge, especially when we are on top or when we look at the bridge from the road level, which is slightly lower. We want the truss bridge to still remain the key language and the key character of the bridge, and not to be overpowered by this railing, these new members. On the flooring, we wanted to make this bridge more accessible and inclusive. This includes those people with prams, baby prams, or wheelchair. What is the most appropriate material to achieve this? We explored several options. Metal grating, which is you put a metal mesh and grating on it. It will be stable, it will be friendly and easy to use, but does it fit our purpose of keeping and retaining the look and feel of this type of truss bridge? We explore granulatic and glass fiber reinforced concrete, and in the end, we decided to bind the ballast stones which is also good. We reuse the existing ballast on site. They were loose ballast, individual aggregate stones. We use cement and grout to bind them together. This is an easy way to also mitigate odd corners and angles because of the bridge abutment. There are some corners that are tricky to handle. And using this binder ballast method, we can also match well with existing because it just feel like we have not done anything, and that was what we wanted to achieve. So we tried different methods and different binding with different gaps and so on, and to ensure quality and workmanship. So this was the various mock-up that we have done, and we were able to achieve something very close to it when we do it on site. And how do we do this binder ballast? So allow me to just share the key sequences. We first have to set up a metal frame to hoist the lift track up, and then we will remove the slippers. We take them and we remove and put them aside to the side. Remove the ballast stones and from the bridge. After that, we actually see that there's this waterproofing membrane that were constructed using asphalt material. They already deformed. They are not performing as a proper waterproofing anymore. It has aged so long, and it's not watertight anymore. So we removed that, and with that we actually managed to expose a very clean and intact steel deck that we see here, except some of the cuts that I showed in the earlier photo. So with this removed, and we then measured the levels again, we found that this bridge actually is constructed at about 300 to 400 mm level differences at the two ends of the bridge. So naturally, water, if they manage to come down to this deck level, they will then they can flow naturally and drain naturally to the other side of the bridge. So to protect the steel deck, we apply waterproofing, several coats of the waterproofing, carry out water ponding tests to make sure that water does not and cannot seep through the steel deck. And after satisfying, we then proceed to apply screeding to protect the waterproof membrane. At both sides of the bridge, we introduce subsoil pipe. This will facilitate the drainage even quicker, so that when water come off to the lower side of the bridge, it can come into this pipe and then drain off directly to the side. And we then backfill the ballast to help create a stable ground for the ballast. We use precast members, precast concrete planks to form the base of the ballast, and then we top up it. We then bring back the ballast aggregates, and then check the levels, make sure they are in the right position. We then reinstate the slippers, bring back the slippers. And at the end, we reinstate the railway track again with proper control to make sure they go back to the same place. After that, then the railing work will start. And as we do all this concurrently, then we then start to use binder ballast method to bind the stones. So how does it look like at the end? This photo is the eventual product of the project. They look the same from the photo, but actually both sides we have about 1.2 meter wide, which is a sufficient width for wheelchair users. And the stones here are all binded by cement grout. So this left side and this right side, they are binded. It is very stable to work on, but in the middle segment, we leave it as it. So you will see loose ballast here. So if you wanted to try working on railway track ballast, you can work on it, and you can enjoy and feel the loose stones. And again, this is another view. And at the end, from far, you really cannot tell the difference between binder ballast and the loose ballast. We also carry out at the same time some enhancement work to the project. Previously, the bridge has no proper access because this was the old railway track, and it is intentional that we don't want people to come onto track. It's a safety concern. But now that this has opened, people have been they climb out steep slopes to just come to this bridge, and they can walk, they can jog since we opened it in 2011. And but it's a good time to make a proper access to the bridge so that it's more accessible. And since then, we then created a new access from there's a building called Real Mall just at the south here. People can then go up properly with a proper steps and then come to the bridge and start their Real Corridor trail. Towards the right is the north, and towards the left in the photo here is towards the south. This garden steps that we created, which is the zoom in of the steps here, is inspired by the timber slipper. So we actually use try to replicate the slipper feel, but actually these are concrete material. So we use concrete material, glass fiber concrete material, but we pattern it that has the slipper look alike. So it can last. It can be more durable compared to a timber slipper, but it offers the same look and feel of a timber slipper. And last but not least, we also introduced lighting because in the old bridge there were no lighting. We simulated several mock-up with a squarish and rectangle shape trunking or pipe trunking. We tested on site and we couldn't compare. In the end, the left one were adopted because we thought the linear structure actually blends better with the steel truss frames and so on. And we installed several lights on the bridge. There are lights on the outside that shines and shows the vertical and horizontal diagonal truss member. So those are RGB color light. You can change color to separate for different occasions. Within the bridge, at the bridge level, we actually installed strip light LED strip lighting within the handrail. So it forms a very nice linear light that shines on the floor to make sure you don't trip on top of the bridge. And at different occasions, this is taken around the Chinese New Year in 2021. So the community celebrate this. We change the color to red color to celebrate the Chinese New Year. And just so allow me to wrap up my presentation. What we did and was we carefully repaired, reinstalled, and refurbished the truss bridges. The Upper Bukit Timah and Bukit Timah both have gone through exactly the same process, just at different location. Previously, the structure was rusty with some corroded or damaged member. There were gaps between them. It's easy to trip and fall on the bridge. There were no safety railing. We came in, repainted and repaired the structures, installed safety railing, improved the floor surfaces and the drainage on top of the bridge. So now and then we then open this to the public and for them to enjoy. On 22nd of March 2021, we opened this place to the public, and this was around the Chinese New Year period where the community start to put in they were recycling things, so they put in some bottles, some flower decoration on bridge, and people come and they enjoy this place together as a community. At the same day, we opened the trail as well. So as shown in the earlier map, these two bridges are the north and south of the central trail area. We open the trail at the same time, and people, you can see wheelchair users, cyclists, people with prams, they enjoy using the space together and this new area that they have access to. There were overwhelming interest when we just opened the place. It gets really crowded over the weekend. The few weeks immediately after the March 2021. Today, the situation is much better now, but generally over the weekend we still or public holiday we still see a lot of people come to Rail Corridor to enjoy the place with their families and friends. And with this, that's all for my presentation. I hope I managed to share with you some of the experience that we have gone through for the Rail Corridor truss bridges in Singapore. Thank you so much.
Thank you, Kia Fu, for bringing us through in very great detail the restoration of two of these critical landmarks in the center of Singapore. For those of you who are not from Singapore, these two truss bridges are really how many people mark the distance going up the trunk road of Bukit Timah. Imagine you're the M1 up from London to the north, right? There are some landmarks. These two bridges from 1932 are those landmarks. And for a long time, as a planning authority, we were struggling with whether we could keep these two for reuse because of the competing concerns of traffic management of the trunk roads below. So luckily, we were able to rethink our entire planning approach to not prioritize road growth or traffic growth. And this allowed us to rethink the retaining of these two bridges. So any questions from the audience that we have with us this evening? Right. Okay, let's see. So Kia Fu, look at the questions too as well.
Yeah.
Okay, I think the first two questions, Kia Fu, if you can answer, that'd be really good. On the construction duration and costs, and the second one about engineering drawings. I will take the third question later from Matthew Shaw.
All right. To TMT, the construction duration was about 1.5 years. And that coincide with COVID. And major difficulties. So I think the difficulties were the authorities' submission. Of course, where we have to reconstruct this bridge, the engineers do have to show to the Building and Construction Authority that they do have a good understanding of the bridge materials and how they're going to repair it. We then also have to justify that the bridge is indeed sufficient to use as a public space at the end, because previously, although in a layman you would imagine a bridge that was previously used by heavy trains, definitely you don't foresee a problem with people walking on it. But we do have to go through this journey to make sure that to justify and satisfy ourselves that the bridge is indeed safe, and to use when the users are changed from train to pedestrian and cyclists. And I think the challenges we faced back then was also COVID, where we have to do in Singapore, we stopped a few months of construction work because of COVID, and then we resumed it carefully. That there were, we call it safe distancing and all these measures. Yep. The cost was for these two bridges, it was about 800,000 Singapore dollars. Yep. Let me go into the second question, original engineering drawing. Nope. So to John Word, we did not have any original drawing. We tried to search around. What we managed to find was only the history part, who built this and who designed the bridge and so on. We did not have any other drawings and information. Therefore, we have gone through the structural investigation process and the documentation process to re-establish all this information.
Yeah, thanks for that, Kia Fu.
Yeah.
If I can add on to the question about major difficulties, I would say that maybe it's not a major difficulty, but in terms of the future of this rail corridor, after the cessation of the railway service from Malaysia to Singapore, there were quite a few years spent thinking about its future. One idea was to divide up the land and have them developed with adjoining land parcels. But fortunately, there was so much publicity around the same period about the success of the High Line in New York that bolstered the ideas that my colleagues also had, that we might want to convert this rail corridor into a cross-island nature or semi-natural reserve. But from this perspective of a natural reserve, we are in Singapore at the moment still trying to come to a balance between, coming to a balance between natural heritage and cultural heritage, because this railway line is a site of cultural industrial heritage. But there's also a lot of nature in that sense. There's plants, etc. So what is the right balance between cultural heritage conservation and nature heritage conservation was something that the team had to work through quite closely with the Parks Department's colleagues, who are URA's other partners in this project. So this was something that all of us had to learn a lot about, including, for example, trying to rediscover the lost railway communities along the road, about their stories. What you may not know is that while the railway was in Singapore, it was run by the Malaysian government, the Malaysian Railways. So all the employees who have been familiar with the railway, after the cessation of the service, they all went back to Malaysia. So that also presented a gap in the knowledge of what's going on, right? this question about railway closed, what other public transport provision was replaced? We are we were planning for a new high-speed rail connection between Malaysia and the west of Singapore. Due to changes in priorities in the Malaysian side, that has not been realized till now. So at the moment, if you wish to take the railway into Malaysia, you have to go to the north of the island at Kranji and take the train from there into Malaysia and continue. But for most commuters, you'll be taking the bus or the metro system from the north to the south. For a long time, the railway service from Malaysia to Singapore was focused very much on cargo, if I remember. And the passenger service, I think there were only 4 a day. It wasn't as frequent as perhaps many people thought it would be. Yeah. So I hope that gives you a bit of explanation. Kia Fu, I think there's the next question about the delay and further enhancement work. And EIA.
I think the delay was minimal. Because this project was carried out concurrently with the trail, and the 800,000 that I mentioned was only for the 2 bridges. Concurrently, this rail corridor central, we are running multiple refurbishment work at the same time. We were refurbishing also the Bukit Timah railway station, and slightly north of here, we have the 9-mile platform that I do a brief introduction just now. We also we're constructing a pedestrian. Oh, sorry, I forgot to put on my laser pointer. We were constructing a pedestrian underpass here. We were refurbishing the railway station at the south, and slightly north. We are creating a new entrance point. We call the 9-mile platform, which is the 9-mile of the previous milestones. So all these happen concurrently. So the delay actually were not significant, and we managed to keep the time frame largely on time. So the next question is the future enhancement work around the bridge. So as we repair the bridges, we did the nearby works as I just explained. And further north, our colleagues from the parks department, the whole rail corridor is about 22 kilometers long. So when we come in to do the central part, the south was almost done, and we came to do the upgrade or refurbish the middle, and the north then start after the completion of the central. And by today, 2023, the north stretch actually also have completed. Then environmental impact. So there were, I'll say, little environmental impact as we do all this refurbishment work. We did not want to disturb the nearby surrounding area. As you can see from this map here, we have it is a Google Map based map, and this large green area is the Bukit Timah Nature Reserve. So the rail corridor actually is just beside the railway. It's just beside the nature area. And therefore, the legend that you see here, which I did not have time to cover today, actually is you can see this green stretch here and the red stretch here. So at different stretches, we actually use different pavement material. These are the trail locations. These are not at the bridge. We use different trail material to refurbish the track. So back then, during the railway time, it was just a railway track on sleepers on ground, and it became muddy when it rains, and the ground was not properly stabilized. So at different locations, at different stretches, we use different pavement material. So you can see here from the pictures, these are the what we call improved ground. We tested several pavement material in 2017, and in the end, we went ahead with this what we call porous binder aggregate. It looks brownish, which resembles the ground color. When it rains, water will seep through it. It's very porous. Water will seep through it directly, and then go into the ground. And by doing that, actually, we do not have to construct any new drains along this corridor, which in many new development you would expect people have to build proper floor, proper slab, and walkway with a new drain at the side. But at this rail corridor project, we avoided that intentionally. And you can see from this middle photo, sorry, it's a bit shaded, blur here. So I mean the color is faded. You can see existing streams. They are working. They they flow very well. There are fishes. You can see dragonflies and all these. And we still keep the greens on both sides of the trail. Yep. How often will this bridge be checked? In Singapore, we have a typical inspection regime. We call this a periodic structural inspection. Most of the building in Singapore, they are checked every 5 years. It's required by the Building and Construction Authority, where building owners have to engage qualified engineers to carry out visual checks on the building for any structural defects, and the engineers will then recommend any repairs or will recommend if further investigation is required. So these bridges they will be checked every 5 years by our parks colleague. Who own these bridges? Calvin, correct me if I'm wrong. I believe they were previously owned by the Malaysian Railway, and when they returned the whole railway track to Singapore, this was left as part of the structure there, and then our Singapore Land Authority, which is the land agent or the authority who manages all the land in Singapore, they then took over this bridge and they maintain it before we do the refurbishment work. But and after we carry out this refurbishment work, these bridges and the trail, it became like a park in some sense. So then the parks department then take over and maintain them from the opening onwards.
Exactly, they were owned by the Malaysians before. Yes. Okay. That your Harriet is surprised at the rails have retained, as they could be a significant trip hazard. I think that has been one of the big debates about the treatment of the surface of the bridge and the rail corridor. What Kia Fu hasn't really shared has been that in the past 10 years, I think we slowly worked with the different communities of heritage enthusiasts, nature enthusiasts, neighborhood groups, interest groups, to really come to talk through what is the balance between heritage retention, authenticity, and safety accessibility. It was really quite a complicated conversation, right, Kia Fu?
Yep. So we have to strike a balance between different stakeholders, and you're right. There are tripping hazards, but what we can do to mitigate that, as you can see from this picture, we took this chance when we do this binder ballast material, we flush it with the slipper. So there are actually only 2 levels here that we are talking about. The binder ballast, which flushes with the slippers, and the railway track, which is we hope is obvious enough for people to know that it is there, and people they can either stand on it or they have to be careful and not trip over it. But beyond these 2 difference of levels, the rest are all they're all flat, and there's no other tripping hazards. Yeah.
I'm just wondering whether or not there are members of the audience with similar experience with refurbishment elsewhere in the Commonwealth that we could share with us at some point. I think one of the challenges we had with the original structure was trying to get our hands onto archival architectural and engineering drawings to better understand the site. And unfortunately, while I think Dorman Long is a fabled engineering and steel firm in the past, at least right now from Singapore, and because of the war and everything, lots of archival information has caused things to go missing. So very often we face a challenge of trying just to understand the original performance. Yeah. So not sure if anyone in the audience here has suggestions on where else such engineering information could exist within the different archives. Well, you don't have to give me an answer now, but if you do, drop us a line. I think we are quite interested. Len.
Have you contacted the National Railway Museum at York at all? Because they might have the civil engineering material in their archives?
No, we have not, but thanks for that. I think we can definitely make a connection even after the current stage, because it will be useful reference for future works. Yeah.
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 I'd just like to take this opportunity to congratulate you on an excellent job. I lived in Singapore for 2 years and remember these bridges. I actually lived next to the railway line near Wessex Estate. So,
Ah, that's really great. That's great. Thanks for joining us. I'm not sure about Kia Fu, but I grew up in Queenstown near Tanglin Halt, and my
all right.
primary school was on the other side of the railway from Wessex Estate. So
Well,
as a child of maybe 8 or 9, going to the railway and looking at trains going by was such an adventure for us.
we're probably on opposite sides of the line.
Yes, yes. And we were told that we mustn't cross the line because it's dangerous or going to Malaysia, etc.
Mhm.
But just to share with the audience here, what is going to happen next in Singapore would be the restoration of the main railway terminus building in Tanjong Pagar, a very important 1930s steel and concrete construction in the, can I say, Art Deco style. That should be starting in the coming months, and that will be another milestone project for, I would say, railway heritage in Singapore. I think Singapore was always planned to be the southern terminus of the Trans-Europe, Trans-Asia rail network, planned in the 1930s, but interestingly, maybe only fully to be fully realized only in this century, with the networks across Eurasia and downwards across Thailand. So if any one of you are planning to come to Singapore in the next couple of years, please do drop us a line. We'll be more than happy to show you more on site and bring you to the rail corridor and exchange knowledge. This is our sincere hope that we can really just learn more. Yeah. Any other final questions for Kia Fu before we round off this session? Megan has already given the link to the forthcoming talk for next Wednesday evening. So if you should come for that as well. Well, if there's nothing else, it just remains for me to say thank you to everybody for making time this Wednesday to join us in Singapore to hear a bit about the railway corridor and the railway bridges. And thank you, Len, for making time to reconnect over the internet. And I'm glad to know that you had a good time in Singapore. Well, hopefully we'll meet up again soon. Okay. Thank you, everybody, and take care. See you next Wednesday.